Welcome everyone to this Tech Talk as part of Viking's involvement in the Joiff Virtual Conference 2021. I'm Simon Barratt, I'm the Foam Product Manager for Viking in Europe.
Hi, I'm Paul Southwood, Business Development Manager for Foam for Viking EMEA. Today we're going to talk a little bit about high expansion foam. So Simon, what is the latest?
Thank you, Paul. Yes, when we was looking at subject matter for our talk to you today, we appreciated that probably a lot of our fellow exhibitors would be talking about fluorine-free.
Yeah.
This is obviously a big subject for our market, our industry, and it's taken up a lot of our time at the moment. But Viking's also involved in systems, and we felt we wanted to just focus on foam systems, not just foam concentrate itself. So looking at that, we get lots of inquiries on high expansion foam. And in fact, the push for alternatives to fluorinated foams, one way is moving to fluorine-free foams, but as we know, some design standards are still not updated in that respect. And we see that some AHJs are actually looking at high expansion as an alternative to fluorine-free.
Okay.
So, Paul, when we look at the detail of these high expansion systems, what do they typically look like?
Well, when you look at a high expansion foam system, they're not dissimilar to any other foam system. And you can see from the graphic there, you're always going to need a water supply. You're always going to need foam concentrate storage. You're going to need a proportioner of some description, depending on the application. Can be used. You can use a pump also. And then it comes down really to the discharge devices for the particular system. Obviously, we're talking about high expansion, so you see we're looking at some racking there. And then for low expansion systems, you'd have low expansion pourers, monitors, sprinklers and nozzles.
Mm-hmm. And I think this graphic is generic, showing all different types of options.
Yep.
But from time to time, we do get asked the question, can we use high expansion foam on low and high systems? So we see this here. Is that something that's possible?
It is possible. It depends on the foam concentrate itself and whether it's been tested for low expansion systems as well as high expansion. So you just need to, obviously contact us and then we can look at the application, look at the risk, and then we can go from there. But it is possible, yes.
Yeah. So I think it is important to remind everyone that high expansion foam systems, they do require a special type of foam concentrates.
Yes.
You look at foam manufacturers' catalogues, and there's tens, if not hundreds, of different products, but certainly a standard type of foam should not be used with high expansion systems. So that's a very brief overview on the system itself, but what kind of applications are we going to use these systems in?
Typically, high expansion foam systems we would use for aircraft hangars, logistics, so large warehouses. We're also using them in areas like engine rooms, where you could potentially end up with a 3D type of fire scenario. By that, we're talking about where you maybe spraying hydraulic oil under pressure.
Right. A rupture of a hose,
a rupture of a hose, or a seal, or whatever it may be. So then you're potentially spraying hot hydraulic oil all around the room. And then we have LNG facilities. Typically, high expansion foam would be used in containment spill pits, and it's there to control the burn off of the gases or the actual fire itself.
Okay. And certainly the projects we're involved with tend to be aircraft hangars, but also logistics, particularly in Europe. Logistics is seen as a good place to use Hi-Ex, particularly by end users, because it gives them the most flexibility. as opposed to installing in-rack sprinklers, for example. But I think that's one of the areas of concern about perhaps the overuse in that type of scenario. What we've got is a very short video now, just to show high expansion foam operating. I think we've all seen the videos on YouTube of a discharge of high expansion foam, normally with some kind of amusing captions, if it's an accidental discharge, for example. But in terms of actually how the foam acts on a fire, I don't feel there's so many videos out there showing that. So what we have here is a typical UL fire pan. It's 3 meters by 3 meters. We've got about 220 litres of, in this case, acetone inside here. The foam generator's to the top left-hand corner, and it's going to be activated. It's just activated now. The fire has actually had a pre-burn of 1 minute, so that fire pan is very hot. The fire is very developed. And what we're wanting the high expansion foam to do is build in volume and actually suffocate the fire. That's its primary target. But also what's going to happen is as the high expansion foam comes into contact with the fire, it breaks down, it drains, and has a cooling effect as well. So what you can see now is that we've got full control of that fire, and in a few seconds we'll get extinguishment, and we see a puff of smoke there. That replicated a submergence time of about 2 minutes. So it was quite a large discharge of foam, but at the same time it was quite a large intensive fire as well.
So, Simon, we've just been looking at different applications for high expansion foam, and I know there's a few design standards out there. So what are the significant or main differences between the different standards?
Yeah, you're right, Paul. There are quite a few different design standards, and some of them, well, a lot of them have some very important differences between the two. I would say the most recognised one is NFPA 11. This is for the design and installation of low, medium, and high expansion systems. Mm-hmm. So, Chapter 6 inside this standard deals with high expansion foam systems and medium expansion, but primarily high expansion. That is giving you a list of possible applications. So, like we mentioned earlier, Class B ignitable liquids, but also Class A combustibles, normal combustibles. It also gives you information on what kind of fires aren't suitable. What I would say is that whenever we were involved with a client that's talking about high expansion foam, we always prefer them to select a standard to work to. I think that's very important, and also not to take cherry picking, taking the best parts of each standard as well. And by best parts, I mean the cheaper way of doing it. Yeah. So NFPA 11 is probably our main go-to, certainly on a global basis. We've then got NFPA 409. Now, this standard is specifically for the protection of aircraft hangars. Okay. So this is covering not only high expansion systems, but it's actually covering the construction, the fire rating, categorizing different types of hangars, for example. Okay. And one of the key, I would say, one of the key parts of this standard is that that it requires a outside air supply delivered to the generator during operation, and I think we're going to touch on that technical aspect a little bit later.
So does 409 also cover low expansion as well as high expansion foam systems?
409 does also cover low expansion systems as well. When you look at 409, there's about 4 different ways of protecting an aircraft hangar. If you go back around 30 years, there was only one way, which was a deluge foam system, which meant a high demand on water supply, on flow rates, and that kind of thing. And sometimes that's still the system of choice, as we know. But the NFPA 409 committee wanted more options. So you've got the option for high expansion.
Yeah.
You've also got the option for ground great nozzle based systems where low expansion foam is delivered from the ground at the ground.
Okay.
There's also scenarios where oscillating monitors can be used as well.
Okay.
Another standard for aircraft hangars is the UFC, Unified Forces Criteria. This is a military specification coming out of the US. And this is used quite often because the US are building military bases around the world, partnering with local governments on these facilities. So this is actually a standard we see very often with high expansion systems. One of the key differences between the UFC and NFPA 409 is that the UFC does not require outside air.
Okay.
So this is a significant difference. And I don't know the full reasons for that, but obviously the military are free to make their own design standards. And when we consider that the fire risk is generally at the ground, it's a fuel leakage. That's a long way away from the ceiling. So I'm guessing there won't be the same buildup of hot smoke and gases like we would get in a logistics centre, for example.
And does that cover all aspects of the military, or is it just purely Air Force?
It's now one standard for the whole military.
Okay.
So that's why it's now unified. There are some caveats inside. So Army, this, Navy, that. So there are some differences, but step by step, it's all coming together, which certainly when we're giving technical support and answering questions, it helps to have some consistency.
Yeah.
Another standard that we use is the FM datasheet 7-93. Again, this is for the protection of aircraft hangars, and it's actually the only application where FM allows or recommends the use of high expansion systems. I believe I'm correct in saying that. So they prescribe in here high expansion systems can be used, but this standard really follows NFPA 409 very closely in that you get the different options.
Okay.
I think the main difference between FM and NFPA 409 is probably FM do give an order of preference. Remember, FM Global are an insurance company. They write these standards to help mitigate the risks. So they actually state in order of preference which systems they would prefer.
Okay.
Then moving more into Europe, we have EN 13565-2, which is the European design standard for foam systems. Within this standard, there's a small section on, again, aircraft hangars. And then there's also other applications noted, such as storage, LNG, as you mentioned earlier. And there's a table at the beginning of this standard which gives an overview of where high expansion can be used.
Okay.
And again, the probably one of the key differences with this standard is that it doesn't require sprinklers as well. So normally in the other standards, you would have high expansion systems and wet systems, wet sprinkler systems. But in the European standard, they actually almost go the opposite way and say they don't recommend it.
Okay.
So again, that's maybe why we see a few more high expansion systems in Europe in logistics compared with the rest of the world.
And is there any issues within that EN standard with inside outside air?
This standard again recommends the use of outside air unless the manufacturer can show test data or an acceptable performance using inside air. Okay. And again, we'll touch on that later with the technical discussions. Within Europe, VDS in Germany, they also have a standard covering foam systems. So this one does go further than EN 13565. It will only allow outside air in their systems,
right,
and it will only allow hydrocarbon Class B ignitable liquids. So in terms of polar solvents, this is something that's not covered by the standard at this time. Then lastly, we have a design standard called APSAD R12. This is coming out of France. But I actually like this standard because it's very much akin to NFPA 11.
Right.
And it's requiring sprinklers. The formula for working out the system is very much the same. But what APSAD R12 does is say, if you've got ignitable liquids, we know that this is a little bit more difficult, or it's a little bit different, let's say. So there is a technical test that as a manufacturer or a foam supplier that you need to perform. That's called APSAD T12.
Okay.
And what this is going to do is basically measure the additional performance we need from the high expansion system to compensate for these large spills of ignitable liquids.
Okay.
That's really the technical and confusing part. What we present in documentation along with our competitors is a TD factor, which is part of the formula. It effectively means how much more foam you need to apply in that area to compensate for those flammable liquids. So I like it because the tests they're not full scale, but they're not small bench tests either.
Okay.
So it's based on sound fire testing, but it's also giving this additional correction factor, which does go further than some of the other standards. And as a manufacturer, we're more and more in design standards. It's saying consult manufacturer. It's always good if we can give solid data back to the customer.
And those fire tests, do we have to go to APSAD to do them, or can we do them in our own facilities?
Those are normally run by CNPP in France, just north of Paris. They have a permanent setup for running those tests. So we find it quite straightforward to go and run the test after we've done our own internal R&D.
Okay. So we've just been talking about all of the different design standards, and one of the topics that came up quite a lot was inside and outside air. You said we'd go on to talk about that a little bit later on. So here we are. So can you explain what we mean by inside and outside air?
Yeah, sure. And you're right. It certainly is a topic that comes up on a regular basis. Yeah. So what we mean by inside and outside air is part of the way a foam generator works is to draw air in to the generator to mix with the foam solution, and that's what discharges that high expansion foam. So because a big ingredient is the air, we talk about the quality of the air going into the generator. And what can happen is if you use air from inside, so that's our term of inside air, then that air might be hot, polluted gases coming from the fire. So particularly in confined, smaller systems like engine rooms, for example, where there's not much possibility of extraction, that smoke can't spread so far because the volume's so low. So what you would typically get is the air being drawn into the generator. It might be hotter than usual. It might have smoke particles in. And what we do know through testing ourselves is it does have an effect on both the output of the generator, but also the quality of the foam that it produces. So when we talk about outside air, what we're doing is bringing in fresh air from outside, which isn't subject to the hot fire and the smoke particles getting into the foam. So what we see on the slide here is in the top right hand corner. That's what we would consider an inside air installation, where the generator's just inside the roof structure. So during operation, it's going to take air from inside that area.
Okay.
Now, if that's a warehouse, a very large warehouse, obviously we've got the fire in one particular area, that any smoke and heat is going to be dissipated over a very large volume.
Okay.
However, like I say, in those smaller areas, you've got more concentration, so it could be more of an effect.
Okay. And when it's hanging in a roof structure like that, is there a limit to how close to the roof it can be, or is that not an issue?
From a flow of air point of view, we normally recommend 300 millimeters minimum from the roof. But what's more important is actually the discharge side of the generator. That's not impacting on any steel girders or walls or anything like that. What we see in the bottom photographs is where outside air is desired or needed as part of the standard. So we said NFPA 409 must be outside air generators. NFPA 11, they're a bit more flexible. You should do that unless the manufacturer can demonstrate suitable performance.
Okay.
So where you do need to use outside air, normally the generator is either installed within the roof structure, and we use a curb and an automatic vent. So the slide on the picture on the left shows from the outside with an automatically opening vent. Okay. So in a fire scenario, that will open and allow the generator to draw in fresh air. And then from underneath, you see that the inlet side where the foam goes in, that's up into that curb structure to bring the foam in. Another way of doing this is installing the generator inside, but then using ducting to go to a vent.
Okay. Thanks for that. And then obviously there are many manufacturers of generators, and they're varying types. So what are the main differences in the types of generator that are on the market now? Yeah,
there are many options, I think, when it comes to generators. I mean, firstly, you have generators for mobile use, which are typically used by firefighters. And these devices are typically smaller than our large fixed system devices, but they can be taken to a room to use high expansion. For example, on the jet 3D fires that you spoke about earlier. But we, for fixed systems, we're not looking at those mobile type of generators, because these generators will always be in place inside the building. So that's one difference we've got for starters, mobile and fixed. Mm-hmm. And then we go to the actual operation of the generator itself. So the first one we have is what's called a blower type generator. This is defined in NFPA 11. This drawing is coming from NFPA 11. And the way the blower type generator is working is it's using a moving fan or propeller, just like you'd find on an extraction fan or a plane, for example. And what that's doing is moving the air from outside the generator to inside the generator. At the same time, we're putting foam solution inside the generator, and then there's an action of that foam solution and the air mixing, and it's going to hit a perforated screen, mm-hmm. which then causes the mass expansion.
Okay.
These are typically operated by the foam solution itself, but there are some models that are electrically powered.
Okay.
For example. Okay.
Yep.
NFPA 11 also defines a aspirated type foam generator. And this is doing the same thing as the blower type generator, in that we're moving air inside the unit, we're mixing it with a foam solution, we're spraying that against a perforated mesh, and then we get expanded foam on the discharge side.
Right. Okay.
The main difference with an aspirated type is it doesn't have the propeller, it doesn't have the fan that's helping to pull and push the foam into the generator.
So how does that work then?
Well, we've still got to get air inside there, because that's obviously a big part of the bubble. And how we do that is through the nozzle technology. So the nozzles through which the foam solution is discharged increases the velocity of that solution through it. And when it's discharged, it creates a Venturi effect.
Okay.
So around those nozzles, there's an area of lower pressure, which means that the air from outside is drawn into that vacuum. So it's a kind of vortex airflow into the generator.
Okay.
But in terms of the ingredients, foam solution and air, and then the physical ingredient in the mesh screen, that's both the same for both generators. It's simply how do we get the air inside the generator to begin with.
Okay. So as a customer, a consumer, if you like, designer, if they were selecting high expansion generators, what would be what are the key advantages, disadvantages, or key features of the different types? What would make you choose one over the other?
It's a good question, and there are some differences. And like everything with fire protection and probably life, nothing's perfect. There's no perfect scenario. So I would say the advantage of the blower type generator is that is given a very big output of foam. So by output, we mean the produced amount of foam. And when we look at design standards, that's one of the key criteria. How much output can my generator give me? So the blower types, because they're assisted with this fan, they're given a good output even at very low inlet pressures. Okay. So that's one of the main advantages of that product. One of the main disadvantages of the product is it's a moving part. And moving parts need to be maintained, serviced. Typically these shafts, propeller shafts, need to be lubricated approximately every 2 years, which is not a big task in itself. The problem is where these generators are installed. We've already said aircraft hangars and logistics centres. And what we know is both those building types are very large.
Yeah.
So it's not uncommon to see hangars at 40 metres in height, warehouses 30 metres, 40 metres, growing in height all the time.
Yeah.
So the actual getting to the generator to perform that maintenance is very difficult.
Yeah.
Sometimes walkways and access areas can be built into it. I've seen that in hangars before, but that's still an additional cost for the contractor. So great performance at low pressure.
Yeah.
But the maintenance is something that's, as an end user, is going to make you think, is there a better way? On the flip side, the aspirated generator has no moving parts, no maintenance requirements itself. And the disadvantage with an aspirated generator is that we don't have the fan. That fan isn't there.
Yeah.
So you're missing some of the injection, let's say, of the air into the generator. We're relying purely on the Venturi effect of that vacuum drawing air into the generator. What that means is there's more of a performance change as we increase in pressure. So the more we increase the pressure, the greater that Venturi effect, so the more air that we draw in.
Yeah.
So you see the performance curve is much more of a slope as opposed to a blower type generator, which is almost a flat performance across its operating range. Okay. So as an end user, what you're going to need is typically more generators because of the like-for-like output. The aspirated one doesn't have that fan assisted.
Yeah.
So normally more generators. That's the downside. That can lead to more water supply, maybe a bigger pump. But on the flip side, you've got something that's simpler in construction. It's lighter to install in these awkward places. And I think the most important part for the end user is that they don't need to go to them every 2 years to operate them or lubricate them. So I think that's the main difference between the two. Both aspirated and blower type generators can be used in all the standards that we mentioned earlier. So yeah, it's a choice between performance and quantity of units or no maintenance further down the line.
Okay. Thanks for that.
Okay.
So moving on then, Simon, we've talked a little bit today about high and low expansion foam systems. So just briefly, why would you choose high expansion foam over low expansion foam?
Okay. I think the first and most important factor is it permitted by the standard that you're using? So we've mentioned a few different design standards today that allow the use of it, but there's also many standards that don't allow the use of it or don't have it as an option for protection. So you may not have a choice. It may be based on the design standard. Where you do have a choice, one of those applications would be hangers. We've already mentioned today that in NFPA 409, in the EN standard, you do have different options for protecting an aircraft hangar. FM data sheet 7-93 as well. So when we look at hangars, it might be a retrofit. So with a retrofit, if that hangar has got it's going from no protection to a fire protection system. If it's been done to NFPA, then you're going to be installing a sprinkler system at the roof and then the high expansion system at the roof as well. So as long as the roof structure can support that weight, then that's why you might choose high expansion.
And an aspirated generator as well because of the weight.
Correct. That's going to keep the weight down, even though you probably need more generators, the overall weight and the point loading is going to be lighter as well. On, again, retrofit of hangars, a floor nozzle system is very difficult. That needs to be designed and built really into the construction from the outset. So that's hangars. When we look at warehousing, which is the other main application, I think that one's probably going to come down to cost of why you would choose high X over low X. So EN 13565 doesn't have a requirement for sprinklers in addition to high expansion. So when you look at the cost of installing a high expansion system compared to a sprinkler system or even an IMBRAC sprinkler system, I think there's a cost element to it, but also a flexibility element for the end user, a high expansion system as opposed to IMBRAC sprinklers. So from a purely cost point of view, that there could be a difference. I think as well there's a technical and assurance point of view as well. Some of the problems we have as a manufacturer is giving guidance when we're asked, will this work? Often we have to say, we don't know if it will work or not because we haven't spent €500,000 to run a full-scale fire test. Whereas with sprinklers, we have a lot of history, a lot of testing, a lot of standards to support the use. So often we would recommend using a low X system over a high X if we just feel the risk is too extreme and we don't have the relevant test data to back that up. So no hard and fast rule. Depends as always. But yeah, I think they're the main elements: the design standard, cost, and then the technical capability of the system.
And how do they compare from a consumption point of view? So water consumption, foam consumption. What's the are they comparable, or is there a big difference between high and low expansion?
Yeah, but it's always surprising to me how much water a high expansion system still uses. You see those bubbles and think, well, there's that's just all air and something else. But the water demand can still be very high. The reason for that is with a high expansion system, we're designing for the whole area operating. But with a sprinkler system, we have a design area of a certain amount of sprinklers. So again, it depends on the size of the area. Typically, a smaller warehouse would have a lower consumption with high expansion. But as soon as that gets large in size, and if it's not sectioned off, then the high expansion system is actually going to have a higher flow and a higher water demand. So again, depends on the particular situation.
Right. We've been talking earlier about foam concentrates and the right foam concentrate for the right application. When it comes to high expansion, I'm assuming the same applies. So can you elaborate a little bit on the foam concentrates that we have for high expansion?
Yeah, sure. What I spoke about earlier was that the foam concentrate that we use must be developed and tested for use as a high expansion foam. Not all foams can be used effectively with a high expansion generator. Yes, you can put it through the high expansion generator, but will it expand? If it expands, at what point will it collapse? So we know through testing that you can't use just any type of foam as high expansion. So what we recommend is certainly fire testing. I mentioned earlier, for example, the APSAD test that involves a fire test, not particularly small scale either, quite a challenging type of fire. And that's going to demonstrate that our foam can firstly expand, that it's as stable as it can be. And we also measure the resistance against the fire, because discharging foam without fire is very different to with a fire. And we need to understand what that difference is between the two. So that's one aspect. Also, it's using the right foam when it comes to polar solvents. Okay. Yeah. So synthetic high expansion foams were typically developed and used for hydrocarbon applications. So jet fuel, that kind of thing. So what we wouldn't do is use the same type of foam concentrate in a hangar as we would in a logistics warehouse that has some polar solvents present. We've seen that in the past from some other companies in the market, but based on really logic and also testing that we've done, we know that we need a specific foam concentrate developed for our high expansion and for also polar solvent. There's a couple of slides that we've just got on the screen here. On the left, you can see that we're running a fire test. There you can see it's halfway through the test with the flames still going underneath the foam. So we need to make sure that eventually we get extinction, that extinction comes within an acceptable amount of time from a technical point of view, but also from a test standard point of view. The photograph on the right is quite an interesting one. This is the standard EN 1568 test. But what we did here was use a standard hydrocarbon foam concentrate to make the high expansion foam, but our test fuel was actually acetone. And what we witnessed is, although on heptane we have a very good performance, but with acetone, what happens is the acetone is constantly breaking those bubbles, and we just don't have enough mass. Whereas with a hydrocarbon liquid, there's not that same reaction.
Right.
So again, it's important to match the foam concentrate to the fuel that we're protecting. And most manufacturers have those two options, but we sometimes see the wrong application within the market, and sometimes the wrong advice given from fellow suppliers.
Okay.
The other thing I would say is that we have fluorinated and fluorine-free options as well. So traditionally, we've supplied fluorinated foams, but like with low expansion, medium expansion, the market's moving to and demanding more fluorine-free solutions. So if you want that fluorine-free option, you've always had that with hydrocarbons because the synthetic foam concentrates don't contain, or the synthetic high expansion foam concentrates typically don't have fluorinated products. But when you move to a special alcohol resistant high expansion foam, then you do need to specifically request a fluorine-free type. But we as a company do offer both.
Right. Okay, so we've been talking generally today about high expansion foam systems, and obviously Viking manufacture a range of high expansion foam equipment, foam concentrate. So I think we'll take the opportunity now just to, if you can just elaborate a little bit on what we do.
Sure. As Paul mentions, we do manufacture our own generators. And quite often we get questions about, well, which one do I use? Why do you have different ones, different part numbers? They kind of look the same. What's going on? Well, as we spoke about design standards being different, quite often test standards are also different. And what we see with high expansion is the criteria that we gain when we test. There's a certain variance in terms of the results, depending where you test, whose standard you're testing to, which assessor is assessing those tests. So it's not as prescriptive as some of the fire tests we do. What that means is we could go to one laboratory with the same device, the same foam concentrate, and get different results because it's tested to different parameters. And then the problem is, what do we put on our data pages? Okay. So we've got basically 3 different types of generators within our range. The first one is what we call our European standard product. That's the product that we have with APSAD as well. We've got test data certification with hydrocarbons and polar solvent fuels. And again, this is the certification where we can use that in APSAD R12, which is giving us that extra correction factor. So even though we've got French certification on that, it's something that we see very interesting in other markets as well. We've then got our VDS type generator, which due to VDS's rules can only be used in hydrocarbon and Class A type of fires. And even though we use the same foam concentrates that we use with APSAD, we have a different performance based on the testing that was done. Right. So to save confusion in data pages, we just have a separate part number for that product. And then we move on to the UL listed generator. That's a new listing that we've got in 2020. And that actually is a different product. Right. There's a slightly different design. It's slightly larger. We've got more effective nozzles, giving us a greater performance. So this has been a move forward we've made this year. Perhaps in time we go back to those other approval standards and test that device. But that is a physically separate device rather than just the same device having a different performance. Okay. Now, what you can see with these 3 generators is all 3 of them are aspirated type generators. As a company, we've listened to end users, and that maintenance cost and that concern about the moving parts is something that really stopped us from developing our own, or moving in the direction of the blower type generators. Previously, we have sold those products very successfully in the past from third-party suppliers. But in terms of our own product development, we didn't see the market wanting us to go that way, which is why we stuck to the aspirating type, as we discussed earlier.
Yeah.
Hope that's been interesting for you as well, Paul, as well as the delegates to the Joiff event. Hope you're enjoying all the different presentations at the event. Please visit our virtual booth. Paul and I are on there waiting for your questions at the moment. So if outside of the virtual event you've got any questions or you want to see more about our products, then you can find us on Viking-EMEA.com.
I think that's it. Thank you very much for your time.
Thank you. Goodbye.